Hello everybody, welcome back to another video of me trying to learn the Zig programming language with the goal of learning and gaining the ability to write systems program in this new language. So if this is the first video of mine you're watching, I am learning Zig through following exercises called as Ziglings made by Chris Bosch. And it's a whole lot of fun programming problems wherein you sort of complete the program by fixing bugs. And I think it's a wonderful way to learn a new language. It makes you think. It's fun. It's essentially the most fun version of lead code, but for learning programming languages. Let's get started. In the previous video, we were looking at slices, the many pointers, and we also looked at immutability in strings and how they are different and unique when compared to arrays. Um, and it was a good introduction to the concept of why slices are important and the benefits of this sort of underlying pointers, um, the pointers and the pointer arithmetic that drive a lot of powerful capabilities. Today we'll look at unions. We'll take a look at the three union examples, and we'll maybe even do a fun quiz to recap all that we've learned so far. Cool. Let's get started. And yeah, a union lets you store different types and sizes of data at the same memory address. How is this possible? The compiler sets aside enough memory for the largest thing you want to store. Cool. I am familiar with the concept of unions. I believe C# just added support for typed unions, which is very, very interesting. Um, mm, and it's, I believe there's a pattern called service result type that's quite popular in identifying um, errors and successful states. I know in Zig we already have this sort of optional values as well as error unions, but the fundamentally the concept is union. Uh, cool. Now let's take a look at the example. The instance of foo always takes up U64 of space in memory, even if you're currently storing a U8. Okay, so when we say a union, this can have this can either be small, medium, large. I believe what they're trying to say is, hey, when we declare a union, essentially we have the option of storing any of these, uh, uh, storing a value of any of these three sizes, but the compiler will reserve the space to accommodate the largest possible value in the union, and therefore all the smaller values will be naturally allowed to be part of it. Cool. I believe that makes sense. The syntax looks just like a struct, but a foo can only hold a small or a medium or a large value. Okay, I get it. So it cannot be all of it. It can be one of it, one of these three possible values. Once a field becomes active, the other inactive fields cannot be accessed. To change active fields, assign a whole new instance. Okay, that is that makes a lot of sense. Um, yeah, essentially, it represents a set of non-homogeneous values, and it can be one of those possible values. But the total reserved space in memory would be large enough to accommodate the biggest possible value. Um, okay, that kind of makes sense. So now we have var f, and we're assigning it small and the value of 5. So we are doing some arithmetic on that particular instance here, and this will work. And it says, hey, there's no error here. But if you try to assign an other possible value, medium, it's going to error out and say, hey, this is impossible. Makes a lot of sense. Cool. Um, Now we can reassign the union again to the variable. Because it's a variable, we can do this. And now we're going to assign medium. Um, Therefore, this particular variable can now access medium, but the others are now hidden away, I believe. Yep, that's right. Unions can save a lot of space in memory because they let you reuse a space in memory. Okay, I see. Because it can be one of these three possible values, as and when needed, we can reassign foo to different ones. And yeah, I can see that. At first, my initial thought when I saw this was, oh wow, um, worst case scenario, we assign unsigned integer of 64 bits, but we always use unsigned integer of 8 bits. How is that optimizing anything? But I see here, like it's the benefit is in how it's reused. And if we, I believe if you take the average case scenario, it's likely that if a union is well defined when we're decomposing the systems into modules, um, there's a if you've designed it well, it's going to get reused and reassigned and therefore utilize the same memory space. Okay, makes sense. They also sort of provide they also provide a sort of primitive polymorphism. That is true. Okay. Similar to function overloading, this is almost on at the primitive data types. It does support it is an example of polymorphism. One because foo can hold many different forms. Cool. Here, foobar can take a foo no matter what size of unsigned integer it holds. That is correct. I didn't even think of it that way. So say we have a function of some sort and it takes unsigned integers, but instead of defining three different functions for three different sizes of input, it is almost like what slices to an array in this particular example, union is to those different possible values of the same type, but a different size. That makes sense. Okay. Oh, but how does foobar know which field? Yeah, that came across my mind. Zig has a neat way of keeping track, but for now, we'll just have to do it manually. Okay, that's good. Manual work means better understanding, and that's what we want when we're learning something new. Now, let's see if we can get this program working. So we have the standard library imported, and we're saying we've just started writing a simple ecosystem simulation. Insects will be represented by either bees or ants. Bees store the number of flowers they've visited that day, and ants just store whether or not they're still alive. Oh, okay. So we're building a simple ecosystem simulation. We have this insect union here, which is a type. And we're saying um, there are two possible things this can hold. If the insect is an ant, then it's going to hold whether it's alive or not. If it's a bee, it's going to hold number of flowers it is visited. For ant. Since we need to specify the type of insect, we'll use an enum. Remember those? Oh yeah, we remember those. Cool. Enum A and B. Ooh, what is this? Where is A and B coming from? Oh, it's whatever we've specified here. Okay. It's one of the possible values of the ant or B type. Cool. Threw me off a little bit because Initially, I was like, oh, what is that? But okay. A is for and, B is for B. Cool. Now, initially, we will say, uh, we have the main function, and we'll say, hey, assign it to an ant, the insect, and we'll say it's still alive. And we'll say to B, assign the union value of uh, flowers visited. I wonder what these are called. What is the idiomatic name for these things? Like I know this together is an union. Is it called? What is the word for that? Is it like a property in the union? I don't know. We'll have to look that up a little later. Cool. And now we'll say the number of flowers visited is 15. Cool. We're printing it here, and there's a mistake here. Oh wow, what's that? Oh, print insect ant or bee, and what is it? So for ant, it should have been A, it should have been B. First, since there's no syntax error, whenever there's no syntax error, we want to run it and experience the error firsthand. I'm pretty sure it's going to say something like C is not a legal value of the ant enum because the possible value is A or B. So it might be something like, hey, it's out of range, or um, something else like that. We'll see. And the print insect function, again, it takes in the insect and what sort of insect it is. And we've taken the manual approach here, obviously, and we're saying if it's an ant, then um, extract the information like this. If it's a bee, do it like this. Makes sense. I'm going to run this program now to see the error. And yes, it says, hey, by the way, the enter B union, I really like how it does this. Entered B is the enum type, but this is the namespace that it's housed under. I don't know if this is called namespace, but my C# brain just automatically calls it the namespace. Cool. So we know what to do. We know we need to change this to A, and we need to change this to B. What a fun example this is. Cool. And we'll say in the first case, the ant is alive and the bee did visit 15 flowers. Cool. That was a fun example. Let's move on to the next example in unions. It is really inconvenient having to manually keep track of the active field in our union, isn't it? Yeah, that is right. Thankfully, Zig also has tagged unions, which allow us to store an enum value within our union representing which field is active. Oh, okay, okay. A tagged union. Cool. I like this. I like this syntactic sugar. So we have an enum here, and we'll say, oh, it can be small, medium, or large. And we're going to pass in, instead of, I shouldn't call it the constructor. I don't know what, maybe it has no special meaning, but essentially we're saying, hey, union, it's almost like a generic, but I do not want to use that word because uh, I don't know. I feel like it, no, I don't think it's generics, but I'm not going to use that word here. It just came to my mind with C# and .NET, but cool. We have an enum here, and we'll say the union, where the properties of the union can be one of these enum values, and depending on what who gets assigned what of these values who gets assigned to, I believe this enum is automatically selected. Now what I want to know, and then I'm going to test out, is what if I remove this? Will this program compile, or will it say, hey, by the way, large cannot be set here because it's not one of the values in the enum? I believe it I would assume it throws an error, but I also don't want to make assumptions when I'm learning something new for the first time. Um, let's see. Now, we can use a switch directly on the union to act on the active field. Ah, okay. Switch expressions almost. Cool. We have a union here defined, and we're setting the small value. And we'll say switch on F. If it's small, do so. If it's medium, do so. And if it's large, do so. And we're saying if it is of type small, then extract the value held in small into this variable. I believe I understand that syntax. Very common. We've seen something similar, although the syntax structure is different. It's what we've seen in arrow functions, whether in C# or TypeScript. Yeah, or JavaScript for that matter, I believe. Now, let's make our insect use a tagged union. Dr. Zorapetra, Zoraptera. Cool, I butchered that name for sure. I'll just call it Dr. Z. Cool, now we have the standard library imported. We have the insect um, stats where it's either flower visited or still alive enum. And then we have the insect itself, and we'll say the stats of the insect here can be one of these. We have the main function, we have the ant initialized here, the bee initialized here, pretty standard from our previous example. We are printing out an insect report, and we're just a line of string, and then we'll say, could it possibly be as simple as passing the union? Print insect, oh yeah, can be. First insect will pass ant, second insect will pass bee, and it'll know how to destructure because since insect is a type of tagged union, it will know depending on what stat was assigned. It will know how to sort of, let's say the word dereference or like extract the right information. Because within the switch statement, we're gonna pass an insect, and we'll say if the active field is still alive, we have extracted the value into ant A, and ant is alive, and we're just displaying the value here. Now, before I run this, it just caught my eye. By the way, did unions remind you of optional value and errors? Yes, absolutely. Optional values are basically null unions, and errors use error union types. That makes sense. That genuinely makes sense. Now you can add your own unions to the mix to handle whatever situations we might encounter. The union, the tag. Okay, toxic goose. Cool. Let me run this and we'll do a quick exploration. Perfect. We're saying ant is true and B is visitor 16 flowers. Oh, one more flower than last time. Yeah, that's nice. Okay, now what I want to do here. What happens if I add an extra thing? Is happy. Cool. Is it going to throw an error? I believe it will, because whatever we're writing here is not a part of this enum. So the tag is not satisfied, but I want to see what happens. Because my thinking is, how will that switch expression work? Because the second we add this, now it's no longer exhaustive. So it's going to either break here or it's going to break here and say, hey, is happy is not a part of this tag. Let's see. Okay, it said no field name is happy in the enum. Perfect. This kind of makes sense. Now we know how I like this approach. I like this approach because it's not a special union type that's defined in a different way from regular unions. It's taking these um, sm- two individual units or constructs in the programming language, enums and unions, and then allowing us to use them together to form a larger, more capable programming construct. I kind of like it, almost like those Linux command line utilities where we have um, small utilities like remove utility, move utility, change directly utilities, and then you can combine them to build bigger programs almost. I like it. I like this approach personally. Uh, Not that my opinion holds all that weight, but just something that I find to be a little joyful in that it's not too many things to be aware of all the time. It's you can build powerful constructs from very small individually capable units. Cool. Let's take a look at the next example. uh, this has been pretty fun unions. Cool. With tag union, it gets even better. If you don't have a need for a separate enum, you can define an inferred enum. Oh, with your union in all in one place. Just use the enum keyword in place of the tag type. This is the advantage of having reserved keywords like that. Common in every language, but I think of all the topics that we have done, I believe I've got a decent understanding of some of them. Some of them I'll have to revise. Some of them I'll have to um, genuinely just write more programs before I can truly grasp it. And even concepts like pointers, which I really, really find fun and amazing to learn. Um, I mean, I get it, but this particular feature, I feel I really like it. Maybe it's because I missed this in C sharp for the last 3 years. I kind of like that the first version of a language has supported, not even the first version. Is it in beta? Yeah, it's in. Yeah, not even the generally available version, but it already has the concept of unions in great detail. Cool. Let's convert insect Dr. Z. Let's convert insect. Dr. Z has already deleted the explicit insect stat enum for you. Cool. We have the union. We no longer have the insect stat, so we're gonna say this is an enum. And since it's a tagged enum, it will still know how to dereference because we can switch on the variable that is initialized with this type, and it'll know how to dereference it. Again, I don't know if the word dereference is right. Generally, it's used with pointers. I'm just again I'm using not so precise technical terminology to describe an extremely precise language, just because I'm learning it more and more. But yes, the end goal is to speak idiomatically, and to truly understand a language, similar to if I were to learn a new language. Cool. We have an and constant, and we have the b constant, and then we're printing it out here. Cool. And we're printing the and b. Yeah, I think we already solved it. It was a pretty straightforward similar to the previous example, as just showing that this does not have to be separately defined. We can just use the enum keyword, which makes a lot of sense. Less verbosity, more simplified. I like this too, but I'm sure there are use cases where we could go either way. Cool. I'm going to run this to make sure we have it working, and then let's read whatever Chris Bosch and the other open source contributors have written here. Cool. We know it works. Let's see. Inferred enums are neat, representing the tip of the iceberg in the relationship between enums and unions. You can actually coerce a union to an enum. Oh, which gives you the active field from the union as an enum. I did not know that. Okay, cool. So you can take the active union. So in for we can coerce an and into an enum, and it would be still alive would be its enum value. Cool. What's even wilder is that you can coerce an enum to a union. Oh, okay. But don't get too excited. That only works when the union type is one of those weird 0-bit types like void. Okay, okay. I have to recollect this again. Let me do that. It's because I took a break in between, and I feel like I forgot what this is. Is this something like where do we write this when there's no error in the program? Do we there's no potential for error? When there's a potential for error, do we write this? I forgot this. I'll look it up a little later, but I've seen this before, I'm sure. Cool. Tagged unions, as with most ideas in computer science, have a long history going back to 1960s. However, they're only recently becoming mainstream. I knew unions were a very old thing because I had read that in my while reading programming books, um, but yeah, I agree with the sentiment. I'm hearing a lot more about unions recently, particularly in system level programming language. You might have also seen them called variants, subtypes, or even enums. Okay, cool. I think I have a grasp of it. Something that I do want to look into is, I believe I was calling these fields of a union. I think it's probably right, but I'll have to look that up a little later. And I also want to understand whatever this void, the exclamation mark is. I remember reading it in one of the examples. I'll have to revise it. Cool. For now, let's take a quick look at a quiz. Ooh, this seems like a fun long quiz. Okay, I think we had a very good exercises on unions. I took a look at the quiz and it is a little bit longer. So I think I'll do a quiz separately as a dedicated video. Essentially, I want to give myself enough time to truly appreciate the quiz, understand it, and not just do a speed run. So we'll call the video there. I think we learned a lot about unions and the tagged unions. I think it was a really good set of examples. But we'll come back in the next video and take a look at that quiz in greater detail. Um, yeah, I think we can call it there. I hope if you're watching this, or even if you're not watching this, and you somehow you're here about Zig or Zig links because of this, I will honestly give the highest of praise for the language, as well as people like Chris Bosch um, who curate these exercises to get people like myself and the people watching into these new programming paradigms. And yep, I think is a net positive is there's a net positive when a lot more of us start thinking in the systems way. I'm gonna call the video there. I think that was a very fun set of exercises. I do want to do the quiz in a separate video. I believe it's going to be a lot of fun to recap all the knowledge that we've gained. So yeah, see you all in the next video. Bye.